Coding for Fun with Dot Bracket Notation. And my name's Andrew Kaechele. My Eterna name is Andrew K. And today I'm happy to be presenting and get excited when I get to share something new with all the diverse and gifted people associated with the Eterna. I have to move this little window because I can't read what I'm doing. But yeah, I'm going to do a walkthrough of decoding some images stored in the structure of player puzzles. If you would like to do some decoding a little later, you'll need some word processing software like MS Word or Open Office Writer and imaging editing program like Photoshop or GIMP. So, but that, and then there's links to the puzzles that I will be decoding, which is paste bin 9 and paste bin 10. And if you want to work ahead and see if you can decode these and see what the images is, and you do, give us a hint in the chat so we know that you did it. That is, if you're just doing it now. If you did it prior, you could hang on to that. But so that's just the page with the downloads for the free GIMP and the Open Office that's in the presentation. But first, I'd like to share a little background on what led to me to encode these images and my thought process. I've been creating puzzles in a series, the Pastebin series, that had side challenges in the comments focused on copying and pasting structure and sequences. It was to emphasize what I feel is the importance of work that takes place in part outside of the interface, and how we as designers get a feel for looking at the dot bracket notation and taking a piece of notation from here and pasting it in. And I don't, we have all these fabulous boosters for a lot of it, but sometimes I just like to work with my word processor and text editor, and in that way I'm keeping files also what I'm doing. But so for the last few puzzles of that series, it was 10 puzzles, and there was some coding challenges in there. I decided to try encoding some images. I'd been aware of images and data being stored in DNA, and a little reading showed that the technology had really matured over the last 5 years since I had kind of heard about it first. And apparently the data is even searchable now, but it's very prohibitively expensive to scale it up. But they think it will be eventually viable. So with that knowledge, and while considering, we'd used barcodes in Eterna before, and I was thinking avatars, signatures, watermarks. So I set to devise a method to store this image data. And I first considered storing the data in the sequence like how they had for the DNA, but decided against that. What I finally decided on, used the low side structure, the right facing brackets and dots only, and it ends at the first external loop. So this left me free to change the high side structure. And since these are puzzles and they're large puzzles, I used the changes to the high side to bend them around to get the pairs on the screen for easier solving. They are a bit tedious. One of them's 3,627 bases. So up here, this paste bin 8, I won't be solving this today. This was the simplest one, and there's a link to it there if you wanted to look at the comments. But so I had to decide on an image format, and I was first drawn to pixel art because it was the simplicity of it, and also because the intuitive file structure used to store these simple images. The first image I encoded, I used a .pbm portable bitmap, which is a black and white format. And the black pixels are represented as ones and the white ones as zeros. And the third line of the file gives the width and height in pixels right here, with the image data on the fourth line. So all that's one line. So I used Visual Studio to split the fourth line evenly onto the 10 lines, and then I highlighted the zero there. So you can see that the image is a one-for-one display of the ones and zeros. You can see there it says Eterna up there, and then this is the actual image that you get when you decoded, which is the image that I made. I used Pixel's GIMP, just started with a 41 by 10 pixel canvas and painted the pixels one by one. And I used as a model, there was font and some of the pixel art stuff that I was watching. And so I used that. So this one's fairly easy to decode. I'm not going to go over this one. If you want to, go for it. But everything's in the description of the puzzle that's needed to decode it, and there's a link. So what I will be decoding, this one is paste bin 9, and it encodes a grayscale image in the .pgm, which is Portable GreyMap format. I originally had GreyMap spelled wrong, so it's spelled a couple different ways. But you know, so if you want to decode this, just follow the instructions and the descriptions to decode. And I'm gonna leave this view, and I'm gonna have to go onto my desktop. And again, here I tried for a wrapped around puzzle that wasn't a long line. And the one hint here, paste unformatted text and have word wrap on in your text editor. I paste everything into the text editor to kind of sanitize it, just out of habit, because you get in trouble with formatting. So I hope this you can see this well enough for right now. This is the paste bin 9. See if I can close that. See, it's so big that it doesn't show up right away in the mini map on the puzzle description. But if I go ahead and open it, it will eventually open. Hopefully I don't crash everything here. Let's see. Yep, there it is. But, you know, it's mostly tedious as a puzzle to solve, you know, filling in all these bases. So we're going to go for the to decode it. Okay. So you would want to copy the entire dot bracket notation. I included it down here at the bottom of the puzzle description. Alternatively, you could load the puzzle and beam it to Puzzle Maker, and you could get it there also, but this is the same. So I copy that, and I want to paste that into my word processor. So, and I want to paste unformatted text. All right, so that's our first step. And now I want to use find. I would just look and find it myself, but we can use find to find where we want to stop the low side. So I should have that find. There it is. Okay, so everything after the last right facing bracket, I want to delete that. Okay, that leaves us with this. And next, we want to go to find and replace, edit, find and replace. So we want to replace one, well, wait back. 1, 2, 3, 4 right facing brackets with 12. Replace all. Got 8 replacements. Okay, so back up the top. Next is 3 brackets with 7. Replace all. 96. Okay. Next one is 2. Replace with 15. As you notice, as this gets smaller, the number of replacements gets bigger. Okay, replace all. 158. Replace 1 with 0. 51, and replace dot with a space. Back space. Okay, so we got placed 312 times. Is my audio okay? Can somebody give me a check? Am I doing okay?
Yeah, it's good.
Okay, great. Thank you. Okay, so we got the replacements done, and a tip here, decoding in that order makes a difference because of just the way it works. If you decode in the opposite order, you don't get the same result. But okay, so now we want to copy these 3 lines, and this is where you want to make sure you don't paste any formatting. But copy that into a new document. I'm going to use my plain text editor. Make sure I don't get no formatting. And then we need to copy the newly decoded structure and paste it onto the 4th line. So I can close this. I'm going to go up here and copy everything, paste it onto the 4th line here. Okay, so it shows here now your code should look like this, but longer. And we want to save the file with a .pgm file extension. Okay, so I save as in documents. Okay, so that was that a .pgm? Huh? Yeah, no, yes, PGM. Okay. Okay, so now if you're using GIMP, my Linux desktop will open these files, but I can go to File. Let's see here. Open and Documents, turn a PGM. And so what is that? Oh, I might have got a little bit of a error there. Nope, there he is, coming out of the depths. Got a gray shark. Caught one. All right. He looks happy though, like he ate Charlie the tuna or something. So we'll have to let him go. So okay, so we'll go straight on to the next image. And this one is paste bin 10. I don't know what I got going on here now. All right. I don't know why. Oh, there we go. Okay. So this is a compressed color picture. I called it an RNA pictogram. A portable PixMap image is coded into the structure of the puzzle. So I want to get some new documents here. Fresh doc there. File. New. There. Okay, so just like before, we're going to copy the entire dot bracket notation. This one's a lot longer. It's over 3600, 3627, I think. Oh, all right, there we got it. Copy and put this in the word processor. Paste unformatted. All right. I probably say all right a lot. Okay, and okay. All right, this one, again, we want to find where where that ends. Find that and delete everything after the last right facing bracket. So it should be right there. Now it should end like that. And it doesn't. Wait a minute. I need to see that again. This is where I need to be. Okay. Delete that. Now it ends correctly. Okay. It ends like it should. And again, the order of replacements matters. Edit, find and replace. This one's a little more complicated. I'm just going to copy them and put them in there. And we're going to replace that. Replaced 5 times. Okay, so this one just takes a dot out of the middle and replaces it with this. Ten times. And if you hadn't already guessed, these numbers are the colors. Should be 5. This is tedious. If I was better with entering data, this would go a lot better. But okay, so 1, 2, 3, 4, 5, 6. Up. Now try that. There we go. All right. See, it's easy to make little mistakes. It's wanting to do the last thing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 4 with 0, 0, 0. Whoa, what happened there? All right. Accidentally hit my keyboard. Having a feeling I might have made a mistake. Yeah, something went wrong here. Oh, well. Well, at least the shark one I got through without making a mistake. I think I have a file. Um, I could start again, but that's going to take a long time because I can tell because I'm no longer getting yeah, okay, well, huh. All right, well, I thought I had a picture of it. Maybe somebody else got it instead of me. ppm. I should have a ppm here, a test of the, okay, here we go. This is what's encoded anyway. I made a mistake. If you make one small mistake in entering data, decoding it, but that's what the first color image that I encoded. And if someone gets it, let us know. That's about all I have today. Glad we got through the shark.
Yeah, thank you, Andrew. Earthsea points out in chat that the find and replace is space sensitive, so be careful. Anyone who wants to tackle this themselves, be careful about when you take the when you're copying the sequence over from the Eterna website. Be careful with that. But yeah, that's amazing. I think we're all pretty impressed that we were able to encode image data inside Eterna puzzles. So that's really cool.
And probably anything, I saw Sinwolf's comment that he wanted to put a Pong game or something in there, so it's kind of wide open. I don't know if anybody had encoded an image in silico RNA to this point, but now there it is. So, and maybe I can go back to my slideshow for a minute. Oh yeah. Yeah, I thought that this might be something fun, interesting, and also useful. Yeah, I'm interested in any further discussion on the structure versus sequence for data storage. And that, in my opinion, we have shown to have a great degree of control when designing for structure. And I just see large strings of what would be like nearly random sequences could be, kind of hard to account for. And if anybody had any questions or comments, um, that'd be good.
I think I know how to do this finally now, Andrew. So thanks a lot. And that was real clear.
Oh, thanks, Esterman. And yeah, and hey, I just here's to the Eterna players, dev researchers who embody the spirit of creativity. You know, that's what keeps driving this whole thing forward, I think, and it's great that we can all be united in that, and really, really something great. So thanks for letting me share that with you today.
Thanks, Andrew. Yeah, I think that's a great note to end
And
Eternacon on.